Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology Section A. In our previous session, we have completed with the explanation for chapter number 5, Heat. Only the last topic of heat exchange is to be explained, that we will see initially, and then we will start with the discussion of textual exercise. Hence, I request all of you to be present for this session with a textbook and a pencil in your hands. So, let us begin with our first topic, heat exchange. Look at the term heat exchange. What does the term mean? That if heat energy it is exchanged between a hot and a cold object, the temperature of the cold object it will go on increasing due to the gain of heat energy. At the same time, the temperature of the hot object it will go on decreasing. Why? Because it has lost the energy. This is the hot object, this is the cold object. If both are made to sit together, then energy will be exchanged between the hot and the cold object, and what you will observe that the temperature of cold object it will go on increasing, while the temperature of hot object it will go on decreasing. Now the change in temperature it will continue till the temperatures of both the objects attain the same value. You have studied about electric potential last year in chapter number 3, Science 1. Similar concept is to be applied here. What happens in this entire process? The cold object it gains the heat energy and the hot object it loses the heat energy. Now if the system of both the objects is isolated from the environment, just imagine they are in the space, no contact with the environment, by keeping it inside a heat resistant box. You can see it is a heat resistant box wherein there will be no exchange of heat with the surroundings. Then what will happen? The energy exchange will take place only and only between the two objects. Then no energy can flow from outside inside the box or come into the box from outside. And what happens in this situation? You get the principle that heat energy which is lost by the hot object is equal to the heat energy which is gained by the cold object, which is known as the principle of heat exchange. What do you mean here? Both the objects they are isolated from the environment. They are in a heat resistant box where no exchange of heat is taking place inside the box and outside the environment. No heat is entering from the environment inside the box, neither heat is coming out from the box into the environment. So there is only the heat exchange between both the objects. And what principle is derived here? Whatever energy is lost by the hot object, that much heat energy is gained by the cold object, and this is called the principle of heat exchange. Our next topic is measurement of specific heat. Last session we have studied about the specific heat capacity of any substance, which depends upon how much of heat energy is absorbed by that particular substance. Here it is the mixing method and the calorimeter. Now the specific heat of any object, any substance, it can be measured by using mixing method, and for this method calorimeter is used. You have studied about calorimeter in the lower standards. Now if a hot solid object is put in the water in the calorimeter, then heat exchange between the hot object. If any hot object is immersed inside the water in the calorimeter, then heat exchange between the hot object and the water and the calorimeter it starts, and this continues till the temperatures of solid object, water and calorimeter become equal. So here the heat which is lost by the solid object which is immersed inside the water, it is equal to heat gained by water in the calorimeter plus heat gained by the calorimeter. So heat lost by the solid object, capital Q, is how much? Mass of the solid object multiplied by its specific heat multiplied by decrease in its temperature. You have studied about the formula when I had explained you the topic of specific heat capacity. One when the temperature is raised and one when the temperature of the object is decreased. Now what will be the amount of heat gained by water? If you are taking it as Q1, it will be mass of water multiplied by specific heat capacity of water multiplied by increase in its temperature. Similarly, heat which is gained by the calorimeter, Q2 is equal to mass of the calorimeter multiplied by its specific heat multiplied by increase in its temperature. So here you can say that the heat which is lost by a solid object, that is the hot object immersed in water, that heat is gained by the calorimeter plus heat which is gained by water inside the calorimeter. So capital Q, heat lost by the solid object, capital Q is equal to Q2 plus Q1. Now here if you know the specific heat of water and the calorimeter, you can immediately find out the specific heat of the solid object by applying this formula. And this formula you have to remember while solving the numerical examples. With this we have completed with the explanation for chapter number 5. Now without wasting time, we will proceed towards the discussion of textual exercise. I request all of you to refer page number 71, textual exercise question number 1. Fill in the blanks and rewrite the sentence. Very simple. Here they have not told us to explain. So only the entire sentence you will write and you will mark the blank. You are going to mark the answer. The amount of water vapor in air is determined in terms of its absolute humidity. You have studied about humidity, relative humidity in the topic when we had covered about dew point and humidity. So you know the amount of water vapor, it is determined in terms of absolute humidity. Second, if objects of equal masses are equal, they are given equal heat, their final temperature will be different. This is due to the difference in their specific heat capacities. We have studied about the iron, lead and the copper sphere. You can say capacity of the object to absorb the heat, even though both are given equal amounts of heat, it will depend on specific heat capacities. Third, very simple, during transformation of liquid phase to solid phase, the latent heat is given out, it is released by the substance. I hope you do not have any difficulties with question number 1. Question number 2 and question number 5 are very important because they are the questions based on graph, and you can assume that such type of questions are going to be asked in the board exams if it is online. Question number 2 says, observe the following graph, temperature versus volume of water, 1 kg volume of water. Considering the change in volume of water as its temperature is raised from 0 degrees Celsius, discuss the difference in the behavior of water and other substances. What is this behavior of water called? You all know that the exceptional behavior of water of expanding, that is known as anomalous behavior of water. We have studied about the anomalous behavior of water. So what is the anomalous behavior? That water, when you heat that water from 0 degrees Celsius to 4 degrees Celsius, it contracts instead of expanding. So how to explain this concept? Now here in this graph you can see that when the temperature of water is raised from 0 degrees to 10 degrees Celsius, you will see that the volume goes on decreasing up to between 0 to 4 and the volume is minimum at 4 degrees Celsius. So that will be your point number 1. If temperature of water is raised from 0 degrees Celsius to 10 degrees Celsius, volume goes on decreasing between 0 degree to 4 degree and is minimum at 4 degrees Celsius. What do you see here? Volume goes on increasing. between 4 degree to 10 degree Celsius. Very simple. You can see in the first case, first point, that when the temperature of water is raised from 0 to 10 degree, volume goes on decreasing between 0 to 4 degree. At 4 degree it is minimum, and from 4 degree to 10 degree volume goes on increasing. Now they have asked, discuss the difference in the behavior of water and other substances. So in the second point, you are going to mention about the other substance. Generally, you know, when any substance is heated, its volume goes on increasing with increase in temperature. Here you can see, with the increase in temperature, volume is decreasing. But generally, when any substance is heated, volume goes on increasing with increase in temperature. So something exceptional for water. Thus, between 0 degree to 4 degree, behavior of water is different as compared to other substances. Means other substances, their volume goes on increasing, whereas in the case of water, between 0 degree to 4 degree, volume goes on decreasing, and this behavior of water is called anomalous behavior of water, because they have asked the last part, what is this behavior of water called? So that will be for 1 mark. This answer can be asked for 3 marks. First mark will be about the volume. Second, you are going to compare about the volume of the substance and the water. And your third mark will be the naming of behavior of water. I hope all of you have understood now. Doesn't mean the way I have presented the answer, same way you are going to represent it in your book or paper. You can write in your own words what you have understood from the graph. Next is very simple. You have to mark the answer. What is meant by specific heat capacity? How will you prove experimentally that different substances have different specific heat capacities? Here the definition is also asked. How will you prove experimentally? So the entire experimental setup and the diagram is necessary. Refer page number 68. I will tell you how to write the answer. Page number 68, that entire activity is given. Try this. Take 3 spheres of iron, copper, lead. Now this part about the procedure, you have to compulsorily write in your own words, because they have told here experimentally. So the first statement you can write in your own words. Take 3 spheres of iron, copper, and mark simultaneously in the textbook on page number 68 under the heading procedure. Put all the 3 spheres in boiling water in the beaker. Take the spheres out of water, and all the spheres will be at a temperature of 100 degrees Celsius. Put them immediately on the thick slab of wax and note the depth that each of the sphere goes into the wax. Then immediately you can write the observations. Iron sphere goes deepest into the wax. Copper sphere goes to intermediate depth. Lead sphere goes the least in the wax. Now here one more statement you have to add. You can see the paragraph below the procedure on page number 68. In that paragraph, first line, the sphere which absorbs more heat from the water will give more heat to wax. More wax will thus melt and the sphere will go deeper in the wax. Then one more observation you have to add. This shows that for equal rise in temperature, the 3 spheres have absorbed different amounts of heat. And then you can define what is specific heat. They have asked what is meant by specific heat capacity. You can see the definition in bold black color on the same page. The amount of heat energy required to raise the temperature of a unit mass of an object by 1 degree Celsius is called the specific heat of that object. No need of mentioning about the units. You can just mention up till here. The specific heat capacity is denoted by letter small c. In your own words again, you have to present this experiment. Now we don't know what way they will ask. Either they will give you the diagram and they will give you the entire setup, that 3 spheres are taken, all the 3 spheres are immersed in boiling water at the same time, they are taken out at the same time. Now when they are placed on a thick slab of wax, then which sphere will go deepest, which will that they can ask. Then what property determines this? Define that property, how it is represented. That can be a type of question, or they will just ask the way it is given here now. Then compulsorily you have to draw the diagram, because experimentally you have to show. Now while drawing the diagram, artistic diagram is not required. Small spheres you can show, give the names and the wax layer. But showing that iron is going deepest, followed by copper and lead. This part is very important. If you show copper to the highest depth, iron upstairs, then you will get wrong or 0 for the diagram. Here we complete question number 3. Now question number 4 is omitted. Just omitted because it is based on the removed part of the syllabus. See page number 67. Always remember, they have given, if we heat 1 kg of water by 1 degree in different temperature range, that part of the always remember is to be included in this answer, and that part they have removed from the syllabus. So we are also going to omit question number 4. Now let us move towards question number 5. Again a graphical question. Question number 5. Explain the following temperature versus time graph. Look at this graph. Time is given in minutes. Temperature is given in degrees Celsius, from 0 degree to 100 degrees Celsius. From this graph, what you understand, you can see ice getting converted into water and then to the gaseous state, that is steam. So in your first point, you are going to mention what the graph indicates, what the graph tells us. They have told clearly, explain. So the above graph is a temperature time graph of ice transforming into water and steam. Now here you can write in your own words what you understand from the graph. Second point you are going to tell. Now you can see here that at 0 degrees Celsius all the ice is getting melted into water, as you can see here in this line AB. So temperature of the mixture, it remains constant at 0 degrees Celsius till all the ice melts as shown by line AB. Now this lines, what each and every line is indicating in the graph, that explanation is very important. In your own words, some will tell that AB shows that at a constant temperature of 0 degree, ice changes to water. Then the temperature at which ice changes to water is called the melting point of the ice, and all in your own words, whatever you understand. Next point, on further heating, temperature rises steadily from 0 degrees Celsius to 100 degrees Celsius, which is indicated by line BC. And at a constant temperature of 100 degrees Celsius, water gets converted into steam, which is shown by line CD. So in this graph, what line AB, BC and CD indicates the change from which state to which state and at which constant temperature, that explanation you have to provide in this by looking at this graph. Now how to express? You have to show the melting point of ice, some will show the boiling point of water. Everything is accepted only and only with proper explanation. With this, we complete up to question number 5. Now we move to the next question. Question number 6. Explain the following. First one, application based question. What is the role of anomalous behavior of water in preserving aquatic life in regions of cold climate? Your first statement should state that in the winter, in the regions with cold climate, what happens? The temperature of the air falls to 0 degree or even below it. You have studied in geography about the tundra region and all. There the temperature in the winter season, it falls even below 0 degree Celsius. So that should be your first point. What happens with the decrease in temperature of the air, of the atmosphere? The water at the surface of the lake, it begins to contract, due to which density increases. Now why we are speaking about the lake? Because they have told in preserving aquatic life. So you are going to speak about the lake, the water surface. Third point, when the temperature of water falls below 4 degrees Celsius, due to its anomalous behavior, water expands instead of contracting. you know how to apply the topic of anomalous behavior. For that, each one of you will refer page number 64, the last paragraph, second last paragraph, sorry. There you know about the exceptional behavior of water, that from 0 degree to 4 degree it contracts instead of expanding. That concept you are going to apply here, that when the temperature of water falls below 4 degree, due to its anomalous behavior, water expands instead of contracting. So as the temperature of water falls to 0 degree Celsius, water on the surface of the lake, it gets converted to ice. As the temperature of water, it falls to 0 degree, we have told here that the temperature of the air falls to 0 degree or even below it. So when the temperature of water, it falls to 0 degree Celsius, what happens? Water on the surface of the lake, it gets converted to ice. But as all of you know that ice is a bad conductor of heat, it does not allow the heat to pass through it. So the water below the ice layer, it continues to remain at 4 degrees Celsius, even though the temperature of air may fall below 0 degree. And at this temperature of 4 degrees Celsius, the aquatic life can easily reside. And thus this anomalous behavior of water helps in preserving the aquatic life in the regions of cold climate. That should be your concluding statement. Again here, how to apply the topic which you have studied about anomalous behavior of water with what is asked, that presentation is very important point wise. I hope you have followed this application based question. Next is again an application based question. How can you relate the formation of water droplets on the outer surface of a bottle taken out of a refrigerator with the formation of dew? You might have experienced this event. A bottle of water which is inside the refrigerator for quite a long time, it is cold. So when you take and keep it outside, after some time you will see the accumulation of water droplets on its outer surface. This appear like dew which you see in the mornings in the winter season on the grasses or leaves. So how you can relate this phenomenon? Your first point is, when the bottle is taken out of the refrigerator, the air around the bottle cools. If you just take a cold bottle and keep out and just try to not to touch, but the area near the bottle, if you just move your hands, you will feel the atmosphere there cool than the normal temperature. So that should be your first point. When air cools due to decrease in temperature, it becomes saturated with water vapor. Now this point you will get in the textbook. You can mark in the textbook on page number 67. Page number 67, in the center of the page you have an activity, try this. Below that activity you have the paragraph. Through these two observations we sense the presence of water vapor. There you will get the second line, second point. When air cools due to decrease in temperature, it becomes saturated with water vapor. Third point also continue marking. As a result, the excess water vapor gets converted into tiny droplets. After droplets, add this part on the outer surface of the bottle, and that tiny water droplets, they are called as dew. I hope you have marked the third point. Page number 67. Below the activity, try this. The paragraph which is below it, second line is your second point. Third line is your third point. You have to add only this one or two words. And in the end, you will say that this is similar to dew which is seen by us in the early mornings. They have asked us how you can relate the formation of water droplets with the formation of dew. So very essential to mention about this similarity with the dew which is seen. You can mention there on the grasses, on the leaves in the winter season in the early mornings. I hope up to question number 6b you do not have any doubt. Question number 6c is homework. In the cold regions in winter, the rocks crack due to anomalous expansion of water. Now in the cold regions in winter, the rocks crack due to anomalous expansion of water. How we have applied just now in the survival of aquatic life. Similarly, you can use that concept and in your own words you can write what happens during the winter season. The cold countries, the temperature it falls below 0 degrees Celsius. Then if water is present within the crevices of rocks, then due to its anomalous behavior, water it starts expanding below 4 degrees Celsius, and you know in the crevices for the expansion of water there is no place, so tremendous pressure is exerted on the rocks due to which it crumbles into pieces. So in your own words you can answer question number 6C. Now let us move towards question number 7, page number 72. You can see this photo of dewdrops I have just placed for you. Question number 7A. What is meant by latent heat? How will the state of matter transform if latent heat is given off? What is meant by latent heat? Your general definition. Here you don't have to mention about fusion or vaporization. So the amount of heat energy which is absorbed or given out by a substance to change its state but at a constant temperature, that is called latent heat. So first you have to mention the definition of latent heat. The amount of heat absorbed or given out by a substance to change its state at a constant temperature is called latent heat. Now the second part. If latent heat is given off, then a gas will convert into a liquid and a liquid will convert into a solid. They have asked, how will the state of matter transform if latent heat is given off? So you will write, if latent heat is given off, what will happen? A gas will convert into a liquid and a liquid will convert into a solid. Very simple. Next question number 7B. Which principle is used to measure the specific heat capacity of a substance? Today itself we have studied about the principle of heat exchange. The specific heat capacity of a substance is measured using principle of heat exchange, and then the principle which is given in the textbook on page number 69. You can see in the bold black font you have the principle. Heat energy lost by the hot object is equal to heat energy gained by the cold object. That is the principle of heat exchange. Question number 7C. Explain the role of latent heat in the change of a state of a substance. You know that a substance, it either absorbs or it gives away the heat energy during a change in its state. That should be your first point. Second, but the main condition is temperature remains constant. That should be your second point. The heat energy, it is utilized for weakening the bonds between the atoms or molecules in the substance. This you have studied while studying about the latent heat of fusion and vaporization. And last, this energy which brings about a change in state but does not change the temperature is called latent heat. Very simple. You have to first mention what happens during a change of state, temperature, how it remains constant, then this heat energy which is absorbed, it is used for what, and then this energy which brings about a change in the state but does not change the temperature is called latent heat. Up to 7C we will stop over here for our today's session. Question number 7D, question number 8 and the additional questions we will be discussing in our next session. Numerical examples, the textual numericals of this chapter and lenses which I will take together when the chapter of lenses will get over. So take a note of it. So after the discussion of additional questions in our next session, I will be starting with chapter number 7 lenses, and hence I request all of you to just go through the concepts of lenses and see if you can link anything about lenses from the previous year's chapter reflection of light about mirrors which you have studied. So that is a homework for you. At the same time, see that your study is going on properly and notebooks are also completed. Regarding the practicals, I will inform to you in the next video. Thank you, dear children.